This TAC is about partial and semi-partial correlation. Specifically, what are they, and why is partial correlation always bigger than semi-partial correlation? Imagine that you want to know if having a school librarian makes any difference to student achievement in a building. Here, the dependent variable is student achievement, and the independent variable is the library program which is delivered by a certified librarian. The overlapping section is the variance in student achievement that is accounted for by librarians. But then an idea strikes you. Hey, aren't the schools with the most money also more likely to have librarians? And aren't schools with most money also most likely to have wealthier kids who tend to have higher achievement anyway? So, how do we know that the psychedelic achievement here is really because of the librarian and not because the school is better funded or the kids wealthier than schools without librarians? This adds a new variable, the effect of money on both student achievement and librarians. As we can see, the variance of this variable overlaps with the variances of the other variables. So you have here the variance shared by money and student achievement, which is represented by the red and purple colors in it. And then you have the variance shared by money and librarians, which is represented by the red and yellow box. And finally, you have that variance in the very center, the variance in student achievement that is shared by both money and librarians. So now for partial correlation. What we want to know is how much influence librarians have on student achievement without the influence of money. In other words, if we hold the predictor of money constant, how much of the remaining variance is explained by the psychedelic good work of librarians? So here's what we do. We take that overlapping variance between money and student achievement, and we subtract it. Then we subtract the overlapping variance in the very center, the variance in the three-colored box. What remains is the psychedelic yellow and purple area, the variance in student achievement that's explained by librarians when the variable money is held constant. And here's what it looks like. These black areas have been subtracted. We figure the ratio of the psychedelic area that is left to the purple area that is left. The ratio of this area outlined in red to the area outlined in white is the partial correlation. That's the amount of the variation that is not explained by our other variable that can be explained by librarians. In semi-partial correlation, we subtract only the area that is shared by the two independent variables. That is the overlap between money and librarians. It's that three-colored box in the very center. The overlapping area between student achievement and money is the box that is both purple and red, is not subtracted from student achievement. The semi-partial correlation then is the ratio of the psychedelic area that is left to all of the purple area, including the purple and red area. The ratio of this area outlined in red to all of this area outlined in white is the semi-partial correlation. Here, it is easy to see why the partial correlation is always bigger than the semi-partial correlation. Compare the areas in these two pictures that are outlined in white. On the left side, the purple area is smaller than on the right side, where the purple area is larger. But the outlined red area in both of these diagrams is the same. So, on the left, because the white area outlined is smaller in the left diagram, the outlined red area in that left diagram is larger in proportion to it. On the right diagram, because the white outlined area is bigger, the outlined red area in the right diagram is smaller in proportion to it. You can see then that partial correlation is always larger than semi-partial correlation. Plug in some imaginary numbers here, and you can see that this is true. And that, my friends, is partial and semi-partial correlation, brought to you in part by your friendly neighborhood librarian.